Hello, this is Ms. DB, and I'm going to show you how to do some of the problems from the 8.3 worksheet, which is on using trigonometry ratios and inverse trig ratios to find angle measures and to solve right triangles. So there's a review on the worksheet of what sine, cosine, and tangent are. You need to memorize these. You need to know that sine of an angle is always equal to the ratio of the opposite side over the hypotenuse. And cosine of an angle is equal to its adjacent side length over its hypotenuse length. And tangent of an angle is equal to the opposite side length over the adjacent side length. If you have those down pat, then you're ready to learn about the inverse trig functions, which are these. If you have a triangle with some given lengths on it, then you can find missing angle measures using the inverse sine, inverse cosine, and inverse tangent functions. So if you know that the sine of angle A is equal to x, then the inverse sine of x equals the measure of angle A. So if we have here that the sine of A is equal to x, then x is what you put here, and the measure of angle A goes there. So that means that if we have, let's look at an example here, if we know that the sine of A is equal, if the sine of 30 is equal to 1/2, then the inverse sine of 1/2 is equal to 30 degrees. And you can use this with sine, cosine, or tangent. If you know what the ratio is, then you can take the inverse of that ratio to get the angle measure. All right, let's look at some examples. First of all, in number 1 and 2, you're going to be using this example right here. This example says that to find the measure of angle 1, we can use inverse sine, inverse cosine, or inverse tangent to find a missing angle measure. So let's see how that would work. Sine is always equal to the opposite of an angle, opposite side of an angle, over its hypotenuse. So I could write that the sine of measure of angle 1 is equal to 6/10, which is the same as 3/5 if you want to change it. That means that the inverse sine, which you show with the exponent of -1, of that ratio is equal to the measure of angle 1. Now, we don't have to use sine. Maybe you like cosine better for some reason. In this triangle, we can use any of them because all three side lengths are given. The cosine of angle 1 is equal to its adjacent side over its hypotenuse. The hypotenuse isn't going to change. That means that the inverse cosine of that ratio is equal to the measure of angle 1. I would get the same answer if I did either of these. You don't have to use your calculator and find these, but you would. I could even use tangent of angle 1. The tangent of angle 1 is equal to the opposite side over its adjacent side. So that means that the inverse tan of 6/8 will be equal to the measure of angle 1. So for the first part of this, to find the measure of angle 1, I could use any of these three methods. And to find the measure of angle 2, you could do the same thing. Now it's going to be a different ratio because they're different sides. So if I want to use sine for measure of angle 2, then I would have to use 8/10. Let's set this up too. So in order to find the measure of angle 2, I could say that the sine of angle 2 is equal to the opposite side over the hypotenuse. Hypotenuse doesn't change, which means that the inverse sine of 8/10 is equal to the measure of angle 2. Or I could use cosine or I could use tangent. So when you do number 1 and 2, you get to pick. Which way do I want to find measure of angle 1? Which way do I want to find the measure of angle 2? You only have to do one way for both. So if I want to find the measure of angle 1, let's say I'm going to use tangent. No particular reason because I can use any one of these. So the tangent of angle 1, I should have put 1 there, is equal to the opposite side over the hypotenuse. So the tangent of 1 is equal to the opposite over adjacent. I think I said hypotenuse. Opposite side over the adjacent side. The adjacent side is 3. that means that the inverse tan of that ratio, 5.2 over 3, is equal to the measure of angle 1. And now I need to find the measure of angle 2. Let's use a different one. How about cosine? So here's measure of angle 2 over here. Let's use cosine of 2 is equal to, that's equal to the adjacent side over the hypotenuse. So that would be 5.2 over 6, which means that the inverse cos of 5.2 over 6, that same exact ratio, is equal to the measure of angle 2. So that's one way you could do number 1. Now you can pick different trig functions. You could use tangent for both of them, but you need to be sure that whatever angle you're looking for, you're using the correct adjacent or opposite side. And then number 2 is just like that. Find the measure of angle 1 using an inverse trig function and the measure of angle 2. You don't actually have to get your calculator out and solve these. You're just going to write it, what the expression would be that you would use to solve it. On the next section, these are pretty simple problems. They're just calculator problems, but you do need to make sure that your calculator is in degree mode. So before you do these problems 3 through 8, check with your calculator that you get 60 degrees when you do the inverse cos of 0.5. Now you might have to click on an up arrow key or an inverse key or a second function key, something like that, to get to these inverse functions. Usually you do. And then once you have it in degree mode, you've checked with these and you got all these are the same answers, then you can go ahead and do 3 through 8 using your calculator. If you are using the calculator that comes with your computer, let's do number 5 using this. I would have to click 1.21 first, and then I have to get to the inverse, so I click this, and then inverse tan. So it would be 50.428. It says round to the nearest degree, so this is about 50 degrees. All right, let's see what else we got here. Now the next part is solving a triangle. Now these are the parts that most students find a little bit tricky when you start doing it. To solve a triangle means that you're going to find the measures of all the angles and all the sides of the triangles. So we already know that angle K is 38. We already know that angle L is 90, and we know side JK is 22. But we also need to find angle J, and we need to find side JL and side LK. Then it'll be solved. There's usually 3 parts that you need to find. There's more than one way to do these problems because you're going to be missing different pieces of information for each problem. So let's look at number 9 and 10 are already started for you. Let's look at number 11. In number 11, we're given one angle is 56, and of course angle R is 90, but we don't know angle Q. We can find that one pretty easy. We can use the triangle sum theorem, and we could subtract the angles that you do know, and you'll find the missing angle measure pretty quickly. So 180 minus 90 minus 56 is equal to 34. So we already know that the measure of angle Q is equal to 34. Next, we need to find either side RQ or SQ. So to do that, we're going to need to use trigonometry. Going with the angle that you know and the side that you know, think about what trig functions would work. So sine is equal to the opposite over the hypotenuse. Sine of 56 equals something over something. We don't know either of those values, so we're not going to use sine. Cosine is equal to the adjacent side over the hypotenuse. So that's going to work because I could do cosine of 56 equals 14 over our unknown there. Cosine of 56 equals 14 over, I'll call it x because I don't like writing 2 variables in for the side length. I'm going to call this x. So now I need to solve for x. To solve for x, what you want to do is you want to multiply both sides by x because it's right now in the denominator. What that does is it cancels it here, and it's no longer in the denominator. And now I can go ahead and write x times the cosine of 56 is equal to 14. X times the cosine of 56. Cosine of 56 is 1 unit. You can't break that up. But I could divide both sides by the cosine of 56. So now I will have x equals 14 divided by the cosine of 56. This is now a calculator problem. Get your calculator out, and my handheld one is better than this, but we can make this work. So I need to take 14 divided by, I'm going to use some parentheses here, and when I do cosine of 56 on this calculator, I have to hit 56 and then cosine, which is annoying. So I need 14 divided by the cosine of 56, and that is equal to about 25.04. 25.04. So that's what x is equal to, which is side QS. I'll put that back in. So I've got two parts of my triangle done. I know what QS is, and I know what angle Q is. One more part to find, and that is RQ. Now I could use Pythagorean theorem, now that I know that this is 25.04, but I'd have to square 25.04, and it's going to get a little bit messy. I think it's easier to use trig. I'm going to go back to my angle 56 and think, well, I know that the adjacent side is 14. I'm really looking for the opposite side. So if I use tangent of 56, that's going to be equal to the opposite side, which I'm looking for, over the adjacent side of 14. This one's a little easier to solve because I don't have a variable in the denominator. So I can just multiply both sides by 14. So 14 times the tangent of 56 is equal to what I'm looking for, that unknown side. And again, you have to use your calculator here. I'm going to go 56 tangent first. Make sure you're not in the inverse table again, or menu. And then I'm going to multiply that by 14, so I don't have to do so many parentheses. So 14 times the tangent of 56 is equal to 20.755? I'll round that to 0.76. And that was equal to side RQ, which was the last thing that I needed to find for that triangle. And 13 will be done pretty much exactly the same as this one, because again, you'll be able to find the missing angle quickly with the triangle sum theorem. And then you'll use either sine, cosine, or tangent to find the missing side lengths. Let's look at number 12. Number 12 is going to be a little bit different, because in number 12, we have that we know two sides of the triangle, but we don't know either of the non-right angles. I'm just going to erase and make a little more room here. So in number 12, I don't know this side here. So if I find this side first, then I'll have something. I am going to have to use inverse sine, inverse cosine, inverse tangent to find the angles. But let's find x first. So in order to find x, we can use the Pythagorean theorem, which says that a squared plus b squared equals c squared. Which means in this problem that x squared plus 31 squared equals 36 squared. Now you should be really good at Pythagorean theorem by now, so I'm not going to finish it off for you. Don't forget that you'll be subtracting whatever 31 squared is from 36 squared. And then when you're all done, you'll get x squared equals something, and you'll have to take the square root of that to get your answer. So you'll be all done, you'll get x equals some number. And it should be less than 36. And, you know, it shouldn't be like a decimal number or anything. The hypotenuse is always the biggest number, so that's a good check. Now let's look at how we would find angle x or angle y, the measure of those angles. I know that the measure of angle, the sine of angle x, let's go with sine first. Sine of x is equal to the opposite side over the hypotenuse. That means that the inverse sine of 31 over 36 is going to be equal to our measure of our angle x that we're looking for. So to use the inverse sine on our calculator, let's clear this out. I have to use this second function key to get to the inverse functions. And I'm going to do 31 divided by 36 Now don't round that, just leave it on the calculator, and then I have to click that I want the sine inverse of that. If you're using a handheld calculator, you most likely click the inverse sine first and then type in your ratio. So the inverse sine of 31 over 36 is 59.44. So our calculators really did most of the work for us. That's what the measure of angle x is. Now I have to find the measure of angle y. Let's see, I'm going to put that this was xw. So the measure of angle y, let's see, can I use sine for that? I could use sine once I find x, but I think I'll use cosine instead, because the cosine of y, change this to green, the cosine of y will be equal to the adjacent side over the hypotenuse, and both of those are given to me at the beginning. So that means that the inverse cosine of 31 over 36 will be equal to y. And then I'll use my calculator to finish it up. So when I'm all done, I'll know what side xw is, and I found angle x, and then I'll find angle y. All right, I hope that helps. Please let me know if you have any other questions, and have a great